Far beyond our home planet lies a world cloaked with ice, so smooth and strange that scientists have called it one of the most fascinating places in our solar system. A frozen moon with hidden secrets beneath its surface. This is Europa, one of Jupiter's largest moons, and possibly one of the best places to look for life beyond Earth. Today we will explore Europa's discovery, its icy shell and hidden ocean, the science behind its structure, the upcoming missions posed to unlock its secrets, and the possibility that life might exist beneath its frozen crust. In 1610, a curious astronomer named Galileo Galilei trained his telescope on Jupiter. What he found changed our understanding of the cosmos. He observed 4 small dots orbiting the giant planets, worlds of their own, distinct from Earth. Those points became known as the Galilean moons: Io, Europa, Ganymede, and Callisto, forever altering humanity's view of our place in the universe. Europa, the 6th closest moon to Jupiter, was among them, slightly smaller than Earth moon. It captured scientific imagination not with fire or storms, but with ice. Jupiter, the largest planet in our solar system, dominates its domain with powerful gravity and rich system of natural satellites. Europa orbits at about 671,000 kilometers from Jupiter, a world bathed in constant gravitational tugging and radiation. Compared to its siblings, Io, a world of relentless volcanoes, Ganymede, the largest moon in the solar system, Callisto, an ancient cratered surface, Europa's surface stands out as unusual, smooth and young, hinting at dynamic internal processes that set it apart. What makes Europa truly unique is its ice-covered surface, one of the smoothest in the solar system. Scientists believe the surface is remarkably young, between 20 and 180 million years old, because there are so few impact craters and many fractures. Across this frozen world, dark linear features, cracks, and straks across the surface. These features, some stretching thousands of kilometers, tell a story of ice under stress constantly reshaping itself. The surface is overlaid with bright water ice, giving Europa one of the highest reflectivities, or albedos, of any moon in the solar system. This suggests a world that is not static but active, a world where the surface interacts with processes far below. Beneath that icy shell, perhaps 10 to 25 kilometers thick, lies something extraordinary: a vast global ocean. Current data suggests this salty ocean could be 40 to 100 miles, or 60 to 150 kilometers deep, potentially containing more water than all of Earth's oceans combined. Europa's density, internal structure, and magnetic signatures indicates an iron core and rocky mantle, such like Earth, but surrounded by this innumerous ocean hidden under ice. But how does this ocean stay liquid so far from the sun's warmth? The answer lies in tides. Doesn't orbit Jupiter in isolation. Its motion is regulated by gravitational interactions with Jupiter and other moons. This creates a process called tidal flexing. As gravity continuously bends and stretches the moon, internal friction generates heat. That heat prevents the subsurface ocean from freezing solid, a process known as tidal heating. This heat could not only maintain liquid water, but might also drive chemical and thermal energy sources, key ingredient for Earth-like life. On Earth, life thrives in extreme environments, from deep ocean hydrothermal vents to frozen Antarctic lakes, where sunlight never reaches. These ecosystems rely on chemical energy rather than sunlight. Europa's hidden ocean may, in theory, offer similar conditions: liquid water, chemical interactions between rock and water, potential energy sources. Many scientists believe that if life could arise anywhere beyond Earth in our solar system, Europa's ocean is among the most promising places to look. But we still don't know for sure. That's where the next generation of space missions comes in. Europa has been glimpsed by several spacecraft. Voyager 1 and 2 provided the first close-up images. Galileo gave detailed measurements in the 1990s, revealing evidence for a subsurface ocean and the unique surface geology. Juno continues to offer new perspectives during its mission around Jupiter. These missions laid the groundwork, but the next steps are far more ambitious. In October 2024, NASA launched the Europa Clipper spacecraft, humanity's most advanced mission yet, aimed at exploring Europa's secrets. Europa Clipper is not a lander. It will orbit Jupiter and perform dozens of close flybys of Europa, sometimes as close as 60 miles or 25 kilometers above the surface. Equipped with 9 science instruments, Europa Clipper's main goals include measuring the thickness and structure of Europa's icy shell, investigating the composition and salinity of its ocean, mapping geology and searching for signs of recent activity like plumes, studying how the surface and the terra interact. While it won't directly detect life, Europa Clipper will gather critical clues about whether Europa's environment could support it. Europa challenges what we thought we knew about habitable worlds. It shows that oceans, and maybe life, can exist in the most unexpected places. As Europa Clipper's data arrives and future missions are planned, we may be on the brink of answering one of humanity's oldest questions. Are we alone?
In Praise of Mystery, a poem for Europa. Arching under the night sky, inky with black expansiveness, we point to the planets we know. We pin quick wishes on stars. From Earth, we read the sky as if it is an unerring book of the universe, expert and evident. Still, there are mysteries below our sky. The whale song, the songbird singing its call in the bough of a wind-shaken tree. We are creatures of constant awe, curious at beauty, at leaf and blossom, at grief and pleasure, sun and shadow. And it is not darkness that unites us, not the cold distance of space, but the offering of water. Each drop of rain, each rivulet, each pulse, each vein. O second moon, we too are made of water, of vast and beckoning seas. We too are made of wonders, of great and ordinary loves, of small, invisible worlds, of a need to call out through the dark.